Welcome back to the session. In this session, I'll be discussing about the format for YARC program. As I have already mentioned that similar to LEX program, we have the YARC file format also. So you can see that there are three sections in the YARC file too. The first one is the definition section. So in the definition section, as like the C declarations, we can make it, and this will be copied into the tab.c file. And apart from that, we have the YARC declaration where we can keep the percentage token, which I have shown you in the previous program. And this is the next section is the rule section where we can write the grammar. The last one is the user subroutine section. So here the main functions will be used, and the function called YY will be invoked. So whatever the commands you want to keep it, that can be enclosed in the slash asterisk and asterisk slash. So the definition section, which includes all the include statement, comment, function, prototypes, variable declaration, all these things we can keep it inside the definition section. Apart from that, there are two important things. Those are the YARC declarations. One is percentage token. The percentage token, which tells you there is a definition for the token. So you can see to that there are two tokens are available. As an example, ID and num. So these two tokens are called as the terminal symbol. I have already mentioned that when we were discussing about the grammar, I have told you these are the terminal symbols. The terminal symbols are nothing but tokens. And one more YARC declarations we have, that is percentage start. What is the use of percentage start is, in order to specify the first non-terminal symbol in the grammar, we can use the start. So you can use percentage start non-terminal symbol, which is an optional one. If you don't want to mention the first non-terminal symbol, then you need not use that. Otherwise, the percentage start will be used with the non-terminal symbol. Say EXPR is a non-terminal symbol which is used in the grammar. So to mention that this is the first non-terminal symbol in the grammar, we can have the percentage start. So these definitions would be available in the definition section. Coming to the rule section contains grammar. In this, you can see the grammar like EXPR colon EXPR plus term, pipeline, term with semicolon. So each grammar is ended with semicolon. And if you want to keep more the rules to be checked, those can be kept in the grammar part with the pipeline symbol. So either you can use this way, or one more way of using the grammar is in this way. The pipeline is in this way. In the previous case, the pipeline is used in a single line, whereas here in the next line, the pipeline is used with the symbols in the right hand side. In the right hand side of the rule, we can say left LHS and RHS. So before the colon, we have the left LHS. After the colon, we have the RHS. In the RHS, you can use the pipeline. So what is the meaning of this is, so when you have addition operation, multiplication operation, or when you deal with the parenthesis, you can use like this. So EXPR plus term, term into factor, then open bracket and close bracket within that EXPR, and we have the two tokens ID and num. So ID is meant for identifier variables, and the number denotes the integer value. So when there is a rule, once the rule is matched, the corresponding action can be performed. So in the action, we can use the symbol value. There are two symbol values we have. One is $, and other one is $I. What is this dollar dollar is? It has the value of the LHS. So how do you assign the value for LHS is in order to to execute the previous routine that will be giving the value. So whatever the routine we give, the previous expression, the previous grammar, from that it will take the value. And $I, which denotes the value of the ith symbol in the RHS. So dollar dollar represent the value of LHS, whereas $I represent the value of the RHS. So RHS will be having terminal symbol or the non-terminal symbol. The terminal symbol, the value is given by the lex, whereas non-terminal symbol, so it has derived from the previous execution of the routines. So the same thing will be applicable to the dollar dollar. So from the right hand side, whatever the expression whatever the execution of the expression in the RHS, based on that, that value will be assigned to the LHS. So in the terminal symbol, whatever the value which we receive from the lex program, whereas non-terminal symbol, the value which is taken from the previous statement's execution. So I'll show you with the example. So if you look at expr colon expr plus term, so in order to add the two terms, two values, in the action part, dollar dollar is equal to $1 plus $3. So how do we position the terms in the grammar is, say if you take expr colon expr plus term, then in this expr is mentioned as $1, the symbol plus is mentioned as $2, the term is mentioned as $3. So if you add $1 and $3, that is the result which is stored in the $. Similarly, when you go to the next grammar, term colon term into factor. So in the action part, $$ is equal to $1 into $3. That is term into factor. And when you look at the third grammar, factor is equal to expression within the brackets, parenthesis. So $$ is equal to $2. So because $1 represent open bracket, $3 represent close bracket. So $2 is nothing but the EXPR. So which is shown here. $1 is EXPR. So here $2 is EXPR and $3 is close curly bracket. So this is what the communication is taking place between the lex and yak, which I have already shown you with the example, how exactly the process is happening. With the animation, we have discussed this part. So when you have the lex and yak, the y.tab.h, which needs to be included in the lex. I will show you the program wherein we have the lex program and yak program. How do we do that? How do we include that y.tab.h? And as I already mentioned, that y.tab.h, which has the token definition. So in the yak, we have the y.tab.h, which needs to be included in the lex, because between the lex and yak, token is moved between these two. So this is used to create the y.tab.h. When you call yak with the -d option, which is used to create the y.tab.h. So the yak program will be created with the extension .y. When you call the yak command with the extension, with the option -d, then which is producing the file y.tab.h. So including this, in addition to the y.tab.h, the one more file which was generated is y.tab.c. So this is one example we have. communication between the lex and yak. If you look at the lex program, so we have the definition section. In the definition section, you can see that the include statement in which y.tab.h is used, which is included the header files. And we have the identifier called ID, which is having the pattern underscore A to Z, capital A to Z, followed by underscore A to Z, capital A to Z, and 0 to 9 asterisk. So what is the meaning of this pattern? What do you get from this pattern is, when you want to declare any identifier, the identifier will be starting with the character. It might be alphabet or it might be start with underscore, followed by either the underscore or the alphabet or the number. So it can have zero occurrence or more occurrence of the following character. So definitely there should be some character, that is either it is the alphabet or underscore. The first character should be either the alphabet or the underscore, and the second character might be there and may not be there, because we have the pattern with the meta character asterisk. Asterisk denote zero or more occurrence of the preceding character. The preceding character is underscore A to Z, capital A to Z, 0 to 9. So it might be there, it might be empty, or one occurrence would be there. So this is to represent the identifier. And coming to the rule section, in the rule section, the pattern is int, character, char, and float. We have, if it is so, the action would be, it returns a token. Token name would be int, char, and float. And if there is a identifier which is mentioned in the curly brackets, so in place of that ID, the pattern would be replaced. If so, then it will return the token as ID. So this is part of the lex. In the lex file, we have the definition and the rules part. Coming to the yak, in the yak, we have only the definition. The whole program is not there. Only the definition is there. The very important things which need to be known between the lex and yak, because while we combine these two, the important thing which is shared between the X and yak is token. So how do we pass the token? How do we have the definition of the token? That's the reason we have the program in which the token definitions are used and return the token as well. So if you look at the yak program, again we have the definition section in which include statements are used. Apart from that, the yak definition with the percentage token, as I already told you, percentage token is meant for defining the tokens. So it is saying that these are the tokens which are being used in the program. That's the reason why do we have this token here. And so by seeing this, we can make out the tokens are int, char, float, and ID. So when the yak is called, then definitely it is creating the y.tab.h, and it has the token definition like this: hash define char with the token code, and for float, ID, and int. So when you see the yak rules may be recursive. We have seen that the yak grammar is having recursive grammars. It might be left recursive or right recursive, and the rules may be ambiguous grammars. So we have seen the grammars, ambiguous grammars also, wherein the Yak is struggling to parse those grammars. And we have the bottom-up shift reduce parsing. So the technique in which the shifting and reducing happens, and which is starting from the bottom to the top. So while doing this parsing technique, so it receives a token, push the token into the stack. It can be reduced. If it is yes, then it reduces the token using a role. If not, getting the another token. So York cannot look ahead more than one token. So there's a problem we had while we have the ambiguous grammars in the program. So wherein it needs to be changed, the grammar has to be rewritten. So we have this example program. I will show you the example program, how the program can be used in the Yak to do the calculation. And I'll give you one simple program. You can see a program which is used to recognize a valid variable which starts with a letter followed by any number of letters or digits. This is one example program. Though we don't have a programming lab, but we will be having some of the program through which you can understand that how the Lex program would be, and how it can be used to do some problems. So that is where we have such kind of program. So here I'm giving one program which consisting of the Lex part and as well as Yak part, so that you can combine together Lex and Yak to solve this problem. So the problem is to recognize a variable which is starting with the letter followed by any number of letters or digits. So this is the Lex program. You can see whatever you are seeing is the Lex program. So in this y.tab.h file is included in the definition section. In the rules part, we have certain patterns, and respectively we return the tokens as well. Now you could see that there is a pattern A to Z, capital A to Z. So it will be returning the token as LET, and that is basically letter. And 0 to 9, there is a pattern which returns the number. If there is a new line, it returns new NL, that is a new line. So if you have any underscore, that is returning US, that is underscore. And if at all you have any character that is dot, which is represented by dot, that will be written as token by using yy text of 0. I have already mentioned about yy text. It's a variable. It has array of characters. So since we have a dot which represents a single character, so we return a single character from the character array. So that's why yy text of 0 we have here. So which is used to return the character. This is a part of the Lex program which has only the definition section, and we have the rule section. So wherever you find a new line underscore, dot, or the integers, or the alphabetic letters. So which is returning tokens correspondingly. Now we'll move on to the YARK program. So this is your YARK program. What you are seeing is a YARK program. So the definition section starts with the percentage open and percentage close, within which we have included the stdio.h. So why do we include this stdio.h? As we know, in C programming, the printf scanfs would be used, for which you are supposed to include the stdio.h. Similarly, here we use printf statement, so that we use the include statement for the header file stdio.h. And you can see the definition. So we have different tokens like a letter, LET, number, NUM, underscore US, and new line NL. So these are the tokens which are defined. So since it is a YARK part, so wherein we have the token definition. And we have the rule section. In the rule section, we have certain grammar. So the grammar would be, the first grammar is, it's a once the input is given, we will be checking whether the input is a valid identifier or not. So when it is a valid identifier, then the printf statement will display it's a valid identifier. So we have a non-terminal symbol VAL colon LET followed by alphanumeric followed by NL. So the statement ends with new line, then that is the end of the input. So further no more inputs are there, so we can wind up the process. So LET followed by alphanumeric. Now you can have the next grammar, that the first grammar is ended with a semicolon. You can see the next grammar. So in the next grammar, ALNUM, so it is a recursive non-terminal symbol. So we use ALNUM as a non-terminal symbol. And in the right hand side, you can see LET followed by ALNUM, or num followed by ALNUM, US, that is underscore followed by ALNUM, or the identifier can be letter, or the alphanumeric can be a number, or the alphanumeric can be underscore. So this is what the second grammar. So these two grammars we have in the rule section, and in the main function we call YY parts. We call YY parts, which in turn will call the YY legs, which in turn it will call YY legs, because we have the parser. Parser, in order to get the token, it will be calling the YY legs. So we have legs as well as YARK. And one more function definition we have, YY error. If at all the grammar is not matched, then automatically YY error will be called, and it says that it's an invalid identifier. It's an invalid identifier. If the input is not matching with any of the grammar, then obviously it falls under invalid identifier. So that's how we have this. So now So how can we run this program? So when you are running the program, how do we run this two programs when you combine these two? So you could see in the command prompt, we have to give the lex command. The lex command has to be executed first. So by calling the file name. In the second line, we call the ya command with the -d extension, and we pass the program name. So from the first line, from the lex command, it creates lex.yy.c. It creates lex.yy.c. And if you see the yark command will create two files. One is y.tab.h. That is what exactly we include in the lex program file. Then one more file is y.tab.c. The y.tab.c is been created. This is a C file, the syntactic analyzer in C, which is created from the yark command, because we have to use the C compiler, for which we pass the two C files. One is lex.yy.c and the other one is a y.tab.c. And we use the library to be included for the program files. So once the compilation is done, it will be generating the a.out. So when you execute the program, so when you are executing the program, dot slash, this is the first output, dot slash a.output. When when the program is executed, because a.out is the executable file which needs to be executed. When it is executed, so we can give the input, say for example variable 1. This is the input when you give, then automatically what happens, this can be processed and it will display it's a valid identifier. Say for example, when you are giving the variable 1, what happens? When it gives variable 1, so first the character V will be taken, that will be matched with the pattern A to Z, so that it will be returning the token as LET. So when it is returning the token LET, what happens? It will be there. It will be a part of the VAL LET. Then we will be reading the next input. So say for example A. So when you read A, again this will be processed by A to Z and capital A to Z, so that it will be returning the token as LET. So when it returns the token LET, what happens? LET, this will be replaced by AL NUM. LET will be replaced by AL NUM. When you have AL NUM, before we have LET, but this will not be replaced by VAL because there is no new line. Still some more input is there. So till we reaches the input 1, that is, till reaches the number 1. That means first input is V, then A, R, I, A, B, L, E. So each time when it is reading the input, it matches with the A to Z and returns the LET. So LET will be replaced by AL NUM. Okay. then it will be replaced by ALNUM, so on, keeps on going, right? So when it comes to the integer 1, so integer 1 will be replaced by num. So what happens now? We have num. This will be replaced by ALNUM. So what happens is, when you have the LET followed by ALNUM, this will be having NL. So LET followed by ALNUM, and new line character will be there. So when you have the new line character, so automatically what happened? Further, no more input. So obviously we have to press enter here. This enter will be caught by the pattern NL, so that you'll be getting the token as NL. So LET followed by ALNUM followed by NL. So once you reach here, so obviously this is according to the grammar what is given here. So when you give the input variable 1, so this will be matched with the grammar and it will be replaced by VAL, and the corresponding action would be valid identifier. So this is what exactly happens when there is a input, then that will be done like this. Suppose if you start with num, suppose if you start with some digits, so automatically what happens? The digit num will be replaced by ALNUM, but there is no such grammar here. There is no such grammar here. So what happens? So automatically it will be calling the YY error, and it says that it is invalid identifier. So this is what exactly happens when you are giving the input and it matches with the grammar and gives the corresponding value result. So in the next session, we'll be coming with the different program, how those programs are used to resolve certain problems. We'll see in the next session.